Have successfully learnt about how to analyze 2D problems inside ANSYS Workbench. Now what we are going to do is we are going to learn how to perform analysis on 1D structures using ANSYS Workbench software. So whenever there is a possibility, you need to be reducing this particular 3D problem into either 2D problem or 1D problems. So what happens if you are able to reduce them, you are going to have a more efficient solution for the same problem, which takes up less time and less cost and less resources to solve, and you will be able to deliver your project more efficiently. Then coming to this particular 1D problems, so if you have a very large steel structure and you want to analyze this steel structure in 3D, it is not that efficient to solve that particular problem, because if you are taking in 3D, number of nodes and number of elements will be more, and you need to solve number of equations and it takes a lot of time and computational effort. But if we are able to say reduce that to 1D, we can solve that problem efficiently. So coming to this particular problem, we are going to take a planar truss here, and this truss is fixed at these two ends, and load of 30 kilonewtons is applied at this point and this point. So this particular planar truss is made up of the Douglas fir wood, which is having the properties of 13.1 GPa Young's modulus and a Poisson's ratio of 0.29, and then it is made up of the rectangular cross section members with height 6 centimeters and width 6 centimeters respectively. Then we are going to solve this particular problem inside ANSYS Workbench and try to find out the deformations as well as this stresses that occur inside this truss due to the application of these three loads. Thank you. In order to solve this particular problem of planar truss, I have opened ANSYS Workbench and I am going to drag and drop static structural onto the project schematic. And once I drag and drop this system, I am going to double click on the engineering data. Now I am going to enter the properties for the material known as the Douglas fir, which is a kind of wood. And once I have entered the name, I am going to drag and drop isotropic elasticity onto this, and then I am going to just type in Young's modulus, which is nothing but 13.1 E9 pascals, and then the Poisson's ratio is 0.29. So once I have given the required properties to this material, I am going to close this engineering data. And now what I am going to do is I am going to right click on the geometry cell and say new design geometry, because we are going to create this geometry for the plane truss. So once the design modeler opens, the first and foremost thing you need to do is you need to check your units. Here from the ruler we can see that our units are in meters, and that are the units that I want, so I don't need to change the units here. So in order to create a truss problem, we are going to create points first, then going to join these 2 points with the lines, and then we are going to apply the cross sections. For that purpose, what I am going to do is I am going to select the point option here, and from the point option I need to select a coordinate file in which I have defined the XYZ coordinates of each and every point that are going to be making up this plane truss. So for that purpose I am going to click here and I am going to just browse, and I have given you a file name as truss modeling data points. You can select that particular data points and press open, and once you open, you need to generate all of these points so that the points appear on this graphics window. So once the points appear on the graphics window, I am going to click on this particular option so that it makes the screen normal to my face. And now what I am going to do is I am going to go to the concept, select lines from points, and I am going to join these particular points. So here every member of this plane truss is made up of same cross section, so you need not worry, you can select and create all the lines in one go. Then I am going to select this point and this point, and I am going to select this point and this point and this point and this point, this point and this point, and then I am going to select these 2 points. See here, so you can select this point and this point, this point and this point, select this point and this point, and select this point, and you can select this point as well. So okay, you need to select this point. Once you have selected all the points and created the lines in the shape you want, you can generate this line body. So right click and say generate. And once you have generated the body, see here a local system has been created where this particular z direction shows the orientation. So for example, if I take this particular member, this particular member is starting from this particular point and is ending at this particular point, or say joint in terms of plane truss. So once I have created all the required lines, then I need to apply the cross section. So our cross section is a rectangular cross section. For that purpose, I am going to go to the concept, say cross section, and I am going to select a rectangular cross section. Now the dimensions of our cross section are 6 centimeters by 6 centimeters. That is why I am going to enter 0.06 by 0.06. So once I have given this particular dimensions to our cross section, now we need to expand this body tab, and in this group I am going to select this line body, and from here I am going to select the cross section. So I have created only one cross section, so there is only one cross section available for selection. I am going to select this particular cross section. And once you see, after applying the cross sections, if you want to check whether the cross section is applied or not, you can go to the view tab, and in the view tab you can select cross section solids, so that what happens, see here, the display has changed from line bodies to the bodies on which the cross section has been applied. So this is how you can model a simple truss. You can also use the same technique to model any complicated steel frames and other sorts of structures, where you can say convert the 3D structure into 1D for analysis. Then once we have completed the design, we are going to close the design modeler. So I am going to now double click on the model cell in order to open the ANSYS Mechanical module to apply mesh and to apply loads and other sorts of things, and post process the solution, and we are going to see all of these steps in the next lecture. Once the ANSYS Mechanical module has opened, now what I am going to do is I am going to go to the geometry branch first, and in the geometry branch I am going to select the line body, and from the line body I need to change the assignment from structural steel to Douglas fir. So I am going to click here and say I am going to change it to Douglas fir, and once I have assigned the required material, then you see a new branch has appeared on the outline tree, which is the cross section. So from this you can verify what are the cross sections that are available in this particular analysis, and once you have done this particular assignment, you can just directly right click and say generate mesh. This is a 1D body. It is very simple to create mesh, and you can directly use the automatic mesher. So once you have finished meshing, you then go and right click, say insert, go to the fixed support. Now you need to be selecting points and edges. As this is a 1D body or a 1D model, you will have only edges or points. For that purpose you need to go to the vertex selection, and then you are going to select this point and this point, and you are going to apply the fixed constraint or fixed support constraint. Then I am going to right click, say insert, I am going to select a force. So I am going to select this particular point and press apply, and I am going to change the defined by vector to components, because I want to apply this particular force in the negative y direction. So I am going to give minus, and the load was 30 kilonewtons. So 30 kilonewtons converted into newtons is nothing but 30E3. So I applied the required force. Likewise, I need to apply the force at this point as well as this point also. For that purpose, what can I do is I can just right click and say copy, and then I am going to select the branch, right click and say paste. I am going to again paste it, and right now I can just select this force to option, and in the geometry selection I can change it from this point to this point. So I am going to select this one and apply. Now I am going to again select this particular point. Now I am going to select this particular force, and I am going to change the selection from this vertex to this vertex and going to apply. This is one way you can apply the loads, or otherwise what you need to do is you need to delete all these three forces. You can select only one force and select these three vertexes at once, and you need to apply a total load of 90 kilonewtons, so that what happens, this 90 kilonewtons will be divided between those 3 points equally. And once you have applied all the required boundary conditions and loading conditions, we are going to solve this particular problem. So once we have solved this particular problem, we are going to see the post processing of the results in the next lecture. We are going to see how to find out the deflections as well as the stresses that occur in each member of this particular plane truss. For that purpose, you can just directly right click on the solution group, say insert, go to deformation and say total deformation. And you can also right click and say insert and go to deformation. You can select the directional deformation as well. As the loads are applied in the negative y direction, most of the deflection may occur in the negative y direction. So I am going to just right click and say evaluate results. So here if I select this total deformation, see the maximum deformation was around 6.72 mm, which in comparison with the length of the say total truss is somewhere around 1, 2, 3, 4. So 4 meters. So with 4 meters of length, 6 mm deflection is not much. Then coming to the directional deformation, we are going to change this from x-axis to say y-axis, and we are going to try to evaluate this particular result once again. And once we evaluate the result, you can see the maximum deflection is occurring in this negative y direction. So we are going to get a deflection of 6, minus means it is in the negative direction. Now we need to find out the stresses that are occurring or that are going to be generated in each member of this particular plane truss structure. But if you just go to the solution and go to the solution toolbar, you just can't click here on stresses, because you see when I click on stresses, what is happening? Nothing is highlighted or no option can be used directly. So what you need to do is you need to right click, say insert, and go to this particular what is known as a beam tool. So once you go to the beam tool, you just select the beam tool group, and you can just right click and say evaluate all results. From this beam tools, you will be able to find out the stresses. So if I expand this beam tool, see here, these are the direct stresses. Direct stresses are nothing but the axial stresses that occur in each member of this particular truss. So what happens? Direct stresses, because in a bar member, what we have assumed is that the bar is going to bear only axial loads, and this particular joints act as a contact between these two members. Then you have the minimum combined stresses and maximum combined stresses. Coming to what is maximum, maximum combined stresses? Maximum combined stresses is nothing but the linear combination of direct stresses and the minimum bending stresses. So in addition to this axial stresses, you are also going to get bending stresses. So the minimum combined stresses are nothing but the combination of direct stress as well as the minimum bending stress. Likewise, maximum combined stresses are nothing but the combination of direct stresses and the maximum bending stresses. Direct stresses, as I have told you, the stress components due to the axial load that is encountered by this particular each element in the truss member. Then I can also right click on the beam tool, say insert, and I am going to go to the beam tool. I can go to the stresses and I can select maximum bending stresses as well. So minimum and maximum bending stress also I can select. Once I selected this one, I am going to evaluate. And see here what happens. This particular stresses will be represented in positive as well as the negative. So what is positive? Positive means the load is positive, means whatever the stresses are being formed, they are formed due to the tensile forces. Negative means it is a compressive stress. So coming to here, minimum combined stresses, see here there is a combination of both compression as well as the tensile stress in the total structure. And you can also identify where there is tension and where there is compression. You can see here there is a tension in this member and this particular member, but coming to these members, they are under some compression. Once we have found out the deflection as well as the stresses that occur inside this particular truss member, we can also find out the reactions at this particular constraints. So one thing you can do is you can just drag and drop this particular fixed support into the solution tab, or otherwise what you can do is you can just delete this one and you can just right click on the solution, go to insert, go to probe, go to this force reaction, and select this particular boundary condition, which is the fixed boundary condition. And once you select the fixed boundary condition, you can just right click and say evaluate results, so that you will be able to know this particular reaction. See here, this particular reaction is 90,000 newtons, or say 90 kilonewtons, which is equal to the amount of force, amount of load we have applied here. So as per the conditions in the linear stress analysis, we have followed the equilibrium condition. In the next lecture, you are going to see how you can perform analysis on a 3D frame. So the main difference between this plane truss and the frame is you are going to have the truss members in the z direction as well. To this particular problem, we have a steel framing system. So steel framing systems provide cost-effective solutions for low-rise buildings. They have high strength to weight ratios and can be prefabricated and custom designed. Consider the following two-story building construction with a steel I-beams. So we need to determine the deformations and the stresses inside the frame due to the application of uniform load of 50 kilonewton per meter, which is applied on the second floor as shown below. So we are going to try to solve this particular problem and find out the deformations and stresses in ANSYS Workbench. This particular problem, I have opened the ANSYS Workbench and I am going to drag and drop static structure onto the project schematic. As the members are made up of steel, we need not change the material. I am going to right click on the geometry cell and I am going to import the geometry. But before importing the geometry, you should go to the properties by clicking on properties, which I have already done, and this properties tab is open here. So in this particular properties tab, while we are going to import the bodies with the lines, we need to select this particular option as well. So if I don't select this particular option before importing the geometry, what happens? Only the surface bodies or the points that are contained in the geometry file will be imported, but the line bodies will not be imported. So before import only, you need to go to the properties and you need to change this particular selection and you need to select this tick box. Once I have selected the required setting, I am going to just right click on the geometry, say import geometry, and I am going to browse. And once I browse, you can select this particular two-story truss frame file, and once I select that particular file, I am going to just double click on the model in order to open the engineering. I am going to double click on this particular model in order to start the ANSYS Mechanical. Once I open this particular geometry, it is showing some question mark beside the geometry branch. So I am going to just expand this branch, and I see there are a lot of members, steel members or line bodies. Okay, I am going to select every line body and we are going to see what is the error. See here, the error is we haven't defined any cross section for any of this particular frame members. So what we need to do is we are going to close the ANSYS Workbench, and remember this has been deliberately done because a lot of people, while they are importing these line bodies, they generally directly import this particular bodies and they don't give the cross section and they come into ANSYS Mechanical. So that is why, in order to show that particular problem, I have done this. Once I have closed this ANSYS Mechanical, I am going to double click on the geometry cell in order to open design modeler. Now what I am going to do is, as per the specification, this particular members are made up of I cross section. So what I am going to do is I am going to right click, say generate, and once I generate this particular structure, I need to apply the what you say as the cross section for this particular members. So as I told you, this particular members are made up of I cross section. I need to go to this concept. I am going to select the cross sections. In the cross sections, I need to go to the I section. Until now we have seen rectangular cross section. Now we are going to see the I cross section, and once I go to the I cross section, I need to be defining this particular properties for the I section. So if you don't know what W1 means, what W2 means, you can just go to this graphics window to get a reference. So for example, if you say what is W1, W1 is nothing but width of this particular flange. Likewise, say T3 is thickness of this central section. So likewise, you need to give this particular data, and this particular problem is defined in meters, so I need not change the units. So I am going to leave the units to meters and I am going to enter all these particular properties. The W1 is nothing but 0.1715, and then W2 is also the same 0.1715. Then coming to this one, it is 0.3556, and then this one is 0.0073, and this one also 0.0073, and this one finally this one is 0.0115. So I have entered all the required dimensions of this particular I section, and once I entered this particular section, I am going to expand this particular branch. And now what I am going to do is, instead of always managing 26 parts, what I am going to do is I am going to select every part. So I am going to select every part, and I am going to say right click and say form new part. So I will ask the computer to form a new part, and once I have created the required cross section, then I am going to go to this particular part branch, and I am going to select all of these entities by just clicking on the first entity, then pressing down shift button and selecting the last entity, and then I am going to assign the I cross section to every member. And once I assign the I cross section, we have finished the modeling. Now what I am going to do is I am going to just close this particular design modeler. Now what I am going to do is I am going to just double click on the model cell in order to open ANSYS Mechanical, and it is showing that as we have changed the geometry, it is asking us to refresh the data, and we are going to click on yes. Once it has refreshed the data, it will open ANSYS Mechanical with all the cross sections applied to the frame members. Now it has opened ANSYS Mechanical. So here you can see, when you come to the cross sections branch, you can see there is an I section that is applied to all of these members. In the next lecture, we are going to see how to apply the loads, and we are going to post process the results. We have opened ANSYS Workbench. See here, there is a cross sections group that has been added to the outline tree, which contains the information of the I cross section which we have applied to this steel frame, and the dimensions of this particular I cross section are given here. So once we have verified that the I cross section has been applied to this frame, I am going to just right click and say mesh, and once I generate the mesh, I am going to apply the boundary conditions as well as these forces, and I try to solve this particular problem. And here I may encounter one commonly encountered problem, which is known as the solver pivot error. We will see how to reduce that particular error. For now, what I am going to do is I am going to right click, say insert, and I am going to go to the fixed support, and I am going to select this 6 points, so 6 vertices, and I am going to just press apply. So we have given the fixed support. Now what we need to do is we need to right click on the static structure, say insert, and we need to insert a line pressure. So where is here is the line pressure. So we have to apply the line pressure. So you need to select this particular line and say apply, and you need to change the defined by to components, and in this you are going to give minus 50 E3 because the load was minus 50 kilonewtons per meter. See here, if your units are not in meters, you can go here and change your units to meters from here. Okay, so once we have given the line pressure, what we are going to do is we are going to just right click and say copy this line pressure, and we are going to paste it. So we have to paste it for 7 times. So I have pasted it for So once I paste it for 7 times, now what I am going to do is I am going to select this line pressure. I am going to select this particular edge, and in that I am going to change the edge selection to this one instead of this one. So likewise I am going to change the edge selection for every line pressure and select other edge. So I am going to just select this one, and so once we have selected all the required edges, I am going to select all the edges at once, and I am going to see whether there is an overlap or not. So right now we don't have any overlap, so we have applied the forces correctly. Now what I am going to do is I am going to just right click and say solve. Once I click on solve, the problem is going to be solved. And see, as I told you, there is a solver pivot error. It is being shown here. So whatever the error is being shown, you can just go to the message branch or message tab, and you can just double click on this in order to see this particular warning. So it is showing that solver pivot warnings or errors have occurred, and there are different reasons for this particular solver pivot error to occur. Generally what happens, the first and foremost thing is you haven't given enough constraints to the model. But in this particular model, I think I have given all the required boundary conditions or say constraints. So that may not be the reason here. The main reason here is that we haven't created contacts between these line elements. Generally what happens, if this particular line models are created inside design modeler, this ANSYS Mechanical will effectively create the contacts between two or more members, between the members. But as this particular model has been imported from other geometric CAD system, what we need to do is we need to create connections between all of these particular beams. That is why it is showing a solver pivot error. For that, what we are going to do is I'm going to just click OK, and I'm going to just minimize this, and I'm going to go back to geometry, and I'm going to double click on the geometry, and once again I'm going to open this design modeler. And once I open this design modeler, what I'm going to do is instead of manually creating for every point like this, manually creating connections, I can just select every part, all the 26 parts, and I can right click and say form new part. So what happens, this all 26 members will be acting as a part of a new single body. Then what happens, the automatic connections will be effectively generated by this ANSYS Mechanical only. So once I have done this, I'm going to just close the design modeler once again, and once I close the design modeler, I can just right click and say refresh, so that the data that we have changed in the geometric or design modeler, it will be updated in the ANSYS Mechanical. And once this particular update is done, then we are going to open this ANSYS Mechanical, and then we are going to try to solve that particular problem. So right now what happened, the refreshing has done. So what I'm going to do is I'm going to just switch to ANSYS Mechanical. So now we switch it back to ANSYS Mechanical. Now what I'm going to do is I'm going to just right click and say solve. And if I press solve, now what happens, see, the solver pivot error will not be occurring, because all the joints between these frame members have been created successfully, and we got the solution. And once we got the solution, we can just right click and say deformation, and in the deformation we can see directional deformation or total deformation. And we can also see, I'm also just going to insert, go to the beam results tool. So in the beam results tool, I can see what are the axial forces that are occurring in a member. So here I'm going to select this particular member. I'm going to press apply, and I'm going to right click, say evaluate all results. Once I say evaluate all results, so in this particular member, it is being experiencing an axial force of minus 10423 newtons, or we can convert the units, we can change the units also, no problem. Okay, so if I just right click, say insert, and go to the beam results tool, and if I say bending moment, and I just select this particular instead of all bodies, if I just select this particular member, I can just apply. And now what I am going to do is I'm going to just say evaluate results. Once I evaluate the results, so this is the amount of moment that is being experienced by this particular member. Likewise, you can select any member, or otherwise you can also calculate all these results for the total members. So I'm going to just right click, say insert, I'm going to go to the beam results, and I'm going to go to this torsion moment. Once I go to the torsion moment, here every body in this particular geometry has been selected, so I need not change anything. I'm going to right click, say evaluate results, and once I evaluate the results, I can get this torsion moment for the total body. Okay, so this is how you can use the different beam tools that are present inside ANSYS Workbench to solve 1D problems. In the next lecture, we are going to see how to solve a problem which contains both 1D as well as the 2D surfaces, which may be called as a hybrid model using ANSYS Workbench. going to see how to analyze a hybrid model which contains both 1D as well as 2D elements. So we have taken a model of a two-story building where the floors are made up of concrete and the beams are made up of structural steel, and this particular cross section is a I-beam cross section. Then what happens, a load of 50 psi is applied over on this faces, and we are going to try to find out this particular stresses and deformations that occur inside this particular body using ANSYS Workbench. This hybrid problem, I have opened ANSYS Workbench and I am going to drag and drop static structural, and once I drag and drop static structural, I will be opening engineering data, and we already have the structural steel that is predefined inside ANSYS Workbench. Right now I am going to go to the engineering data sources and I am going to general materials and try to find out concrete. So here in general materials we have a material known as concrete, and I am going to add it for the analysis. And once I selected this particular material, I am going to just close this engineering data. And now I am going to click on geometry cell, and here I am going to import geometry from other CAD system. So I need to select this line bodies. If you don't select this particular option, what happens when you are trying to import line bodies from other CAD files, they won't be imported. So this is very important, as our CAD file is containing both 1D objects which are lines and 2D objects which are surfaces. So once I have selected that particular option, I am going to just right click, say import, I am going to browse, and once I select browse, I am going to select this two-story stage and I am going to press open. Once I have imported this particular geometry, I need to apply the cross sections. So I need to double click on the geometry cell in order to open a design modeler. And as I've told you, in order to avoid solver pivot errors, we also create the total object into a single part. Once I open this design modeler, I'm going to just right click, say generate. And once I generated, all the required lines as well as surfaces have been imported. Now what we need to do is we need to give the thickness to this particular surfaces, and we need to give the cross section to this bodies or say lines. So for that purpose, what I'm going to do is I'm going to go to the concept, go to the cross section, and I'm going to select the I section. And see here, all the units that have been defined are in inches. So what I'm going to do is I'm going to go to the units and I'm going to change it to inches instead of meters. So once I've changed it to units, I can give this particular values. So the first value is 7.07 and 7.07, and this one is 16.25. So once I have given the required dimensions for the cross section, what I am going to do is I am going to just select all these line bodies and I am going to give this particular I section as my cross section for this particular frame. Right now what I am going to do is I am going to select every body and I am going to right click, say form new part. So once I say to form a new part, now I can just close this design modeler, and once I close the design modeler, I am going to just double click on the model cell in order to open the ANSYS Mechanical. And once I open the ANSYS Mechanical, we are going to apply the boundary conditions, perform the mesh, and then solve the problem and try to find out the deflections. And here we also will be drawing a shear moment diagram. So see here, once you have imported this particular geometry from design modeler to structural, it is asking us there is something that is missing. So as I told you, we need to define the thickness of this particular surfaces. So in order to define the thickness of the surface, as I told you previously, the units are in inches. So what I am going to do is I am going to go to the units and change the units from mm to inches. So here I have US customary, so I am going to select this one. So what happens, my thickness is in inches. So I am now going to give this particular thickness in inches. So each floor is of 5 inches thickness. So what I am going to do is I am going to enter 5. So as I have selected every surface body at once, so I need not give this particular value individually. So once I have given the required thickness, what I am going to do is I am going to just go to static structural and say insert, and I am going to apply a pressure of 50 psi. So where I need to apply the pressure of 50 psi, I'm going to apply the pressure on every part of this, so I'm going to apply the load over on the top floor. For that purpose, I'm going to select the pressure and I'm going to select all these three faces. I'm going to press apply. I'm just going to leave it defined by normal 2. I'm going to just give 50 psi. Once I have applied the required load, what I'm going to do is I'm going to just right click and say solve. And once I click on solve, what happens? Does it solve correctly? No, because we haven't constrained the model. So see, you will be getting a solver pivot error. See here, you have got a solver pivot error because here the problem is not the connections, here the problem is the constraints. So what you need to do is you need to just right click, say insert, and go to fixed support, and you need to select these vertices. So you need to select this vertices, and once you select the vertices and apply the fixed support, then you will be able to say generate the results accurately. So once I've given this particular constraints, I can just solve the problem. Now you can see that we won't get any solver pivot error, and our solution is done. And once our solution is done, I'm going to right click, say insert, and I'm going to go to say, see here, once you can go to the solution toolbar, and a lot of types of results are available. Previously, when we have only 1D elements in the model, we didn't have this many number of results. So here you can just click on equivalent von Mises trusses, and you can just right click, say evaluate all results, and you are going to get this particular results on this particular surfaces. But if you want to get the results on the beams, again you need to go to right click, say insert, you need to go to the either beam tool or beam results. So you come to the beam results, and here you can just ask for shear moment diagram. So once you ask for a shear moment diagram, the first and foremost thing you need to do is you need to create a path. So in order to create a path, what you need to do is you will go to the model, and in the model branch you are going to select the construction geometry, and in the construction geometry you are going to right click on the construction geometry, say insert, and you are going to create a path. In the next lecture we are going to see how we can create the path and apply it so that we can generate a shear moment diagram for this particular member. To create a path. So in order to create a path, there are two ways. You can either select 2 points, or you can either select an edge, or you can also create two coordinate systems, and you can apply a path between those two coordinate systems. Here what I am going to do is, in the path type I am going to change it to edge, because I can directly select this particular member so that a path is created on this particular member, and I am going to draw the shear moment diagram. So once I selected this one, I am going to go to the geometry selection and apply the geometry selection to this one. See here, I am going to go to the edge selection, and I am going to select this particular edge, and I am going to apply. And once I have selected that, here see the path has been created. You can also rename the path, let us say beam 1. So beam 1. So I have created a path. Then what I am going to do is I am going to come back to this total shear moment diagram, and in the path I am going to select this beam 1. So once I selected this beam 1, I can just right click, say evaluate all results, so that what happens, see here the shear moment diagram has appeared, and this is how you can create a shear moment diagram. So this is how you can use the ANSYS Workbench in order to solve 1D problems as well as problems which contain both 1D as well as 2D inside ANSYS Workbench. These are very useful in analyzing very large structures in minimum amount of time, and that too efficiently. So in the next section we are going to learn about how to perform model analysis and find out the natural frequencies of different structures. I am going to show you how you can create different beam elements with different cross sections, and how to change the orientation of the cross section or alignment of the cross section inside ANSYS Workbench software. For that purpose, I will be just dragging in the geometry element into the project schematic, and I am going to double click on the geometry cell in order to open the design modeler. So I will be double clicking on the geometry cell so that I will be opening the design modeler module where I am going to create a line. Yeah, it is open. So now what I will be doing is I will be creating 2 points. First of all, let me change the units from meters to millimeters, and now I will create 1 point, and this point I will be creating through manual input. I will be leaving this 0 0 0, so that what will happen, the point which we are going to create will be created at the origin, which is nothing but the 0 0 0. So I will right click and say generate this particular point. Now I will create another point, and here also I will give a manual input of the coordinates, and I will give a 100 mm in x direction, so that what will happen is I am going to create 2 points which are spaced at 100 mm apart in the x direction. See here. So whatever the manual input we are giving that are with reference to the global coordinate system that is shown here. Okay. So now I will go to the concepts, and then I will select the lines from points, and now I have to select these 2 points. So first of all I will select this point, and by pressing Ctrl I will select the second point. Now you can see the preview of a line that is being created between these 2 points, and once you are satisfied with that you can press apply. Now you have created the required line. Just for updating you need to right click and say generate. Now it is successfully created. The line which we want between those 2 created points has been successfully done. Now what I will do is I will go to the concepts and go to the cross sections. What I will do is I will select an I section, and if you want to change the dimensions of the I section you can change them from here, and if you want to see what dimension corresponds to what element here, you can just see it is reference W1, and you can go into the diagram and you can see W1 is nothing but the lower web width. Likewise you can see T1 is nothing but the thickness of the lower web. Likewise you can compare, and you can change whatever the dimensions you want. And once you are satisfied with the dimensions of this cross section, the next thing you need to do is you need to expand this part branch, and you will get a line body. You will get to see a line body because this line body we have created. So in this line body we will go to the cross section, and then we are going to select the I1. See here we have created only one cross section. That is why in selection we are offered only one cross section. If we had created multiple cross sections, we can select from all those multiple cross sections that we have created. But now I have applied this particular I cross section to this line body. Fine. Now I will go to the view options and click on the cross section solids. And once I click on the cross section solids, see here I am able to see the preview of the cross section that I have applied to this particular line. Now the main thing is I want to change the alignment of this particular, let us say, cross section that I have applied. So what I will do is here if I just click here on the line body, there is an option called offset type, and in the offset type it is set to the centroid. Centroid is nothing but whatever the cross section you are going to create, there will be a centroid for that particular cross section. So once you create a cross section and then apply it to a line element, the line element will be aligning with the cross section at the centroid of that particular cross section. Like suppose for example, let us say I section is there, and for an I section at this particular middle point we will be having the centroid. So whatever the line, for whatever the lines I have selected and applied this particular cross section, the alignment by default will be set to the centroid. That means the line which we selected will be passing through the centroid of this cross section. Let us say you don't want to keep it at the centroid, you want to change the alignment, because this will be the neutral axis for the cross section. So in order to change this, you have to come to the offset type and you have to change it to origin. That means whatever the origin is there for that particular element which you have selected, the cross section will be aligned with respect to that origin. Otherwise, if you want to give it manual inputs, then you can change it to user defined, and once you have selected user defined, here you can give offsets. Let us say in x-axis direction I want like 10 mm, and y-axis I want some 4 mm. So likewise I have given particular offsets, and based on that offsets, see here we were able to get that alignments. Likewise, if you want to give any alignments manually also you can give, or otherwise if you want this particular say element to pass through the shear center of that cross section, then you can select the shear center option. But generally what we will do is, by default we leave it to centroid only. The next thing we need to learn is how to change the orientation of this particular cross section. So see here, I don't want this cross section to be oriented in this fashion. So for that purpose what I have to do is, I have to come to the line body and I have to right click, and here there is an option called select unaligned line edges. So I will select this particular one, and once I select this option, see here we are getting some options. So here the cross section alignment is based on plus Z by default. This means what happens is, whenever you apply a cross section to any line that you have selected, what happens that the particular cross section will be aligned with reference to the Z axis, that to a global Z axis, so that you generally will know the orientation of that particular cross section. Now if I want to rotate this particular cross section, what can I do? I can just give 90 degrees so that I can change the orientation. Likewise I can give 45 degrees. Based on your requirement you can give any kind of orientation. And even you can change the directions also. You can change the orientation direction. If I click on yes, so whatever the angle now you are going to give, it will be in the opposite direction. See, okay. So this is the option. And if you want to select any other say edges or lines as a reference for the alignments, you can select it by selecting this cross section alignment option, and you can select the line or anything as a reference and click apply. Now you are able to see that based on this particular line, this cross section is aligned. Now I can keep it to 0 to show you the exact alignment. Because you have selected this particular line, this particular cross section has been aligned with respect to this line, and if I give 90 degrees, it will be perpendicular to that particular reference line. So this is how you can change the alignment of the cross section with respect to the line element you have created, and also orientation also can be changed as per your will. Thank you.